Hey everybody, in this video we're going to be going over function rules. Okay, it's our next lesson in functions, and we're going to talk about what a function rule is and do a couple examples. Awesome, so let's jump in. So in this example here, I have just a couple examples of, well, it's the same way of writing a relation, right? And what we talked about in the last video was how we determine if a relation or a relation is just a group of ordered pairs, and there's lots of different ways we can write those or show those, right? A table, a list of points, a graph. We showed that weird mapping diagram. Um, and so just real quick, let's determine that. Let's determine if this is a function first, and then we'll jump into what a function rule is. Okay, so in this one, right, we look at these points, and the big determining factor, hopefully you remember, is those x values, right? The y values really don't matter. It's the x values, right? And for this one, we see that all the x values are different, right? Yes, -2 and 2, it's the same digit there, but a -2 and +2 are different numbers. So same with -1 and +1, and so on. So because there's no repeating x values, yes, this would be a good function, okay, if it asked for that, okay? And you can see that through the table. Again, you can see it's the same thing, just listing it as points, okay? But I'm just going to graph this here and show you what it would look like here too. So -2 comma 4. So -2 on the x, we'll label these. -2 on the x, 4 on the y, will take me up here. -1, 1. Here, I'll graph these here quickly. 0, -2 here. And as I graph these, hopefully you're noticing a little bit of a pattern. 1, -5, and 2, -8. All right. Yes, so if you look at this graph, okay, I hope that you would see that, yes, there is a pattern, okay? If I played connect the dots here with these, it would form a line, right? It would form a line, a straight line. And that's something we'll talk about more in Unit 4 is graphing lines. But in this one, let's talk about that. What makes this a straight line when I graph it? And that's going to be looking back at the table. Okay, if you noticed in the table as well, it's not just a random collection of points like I showed in the last video, but there's a pattern to it. Okay, look at the x values, -2, -1, 0, 1, and 2. So the x values are all increasing by 1 each time as you go down, and that's easy to see, okay? But then you look at the y values too, there's a pattern going on there, okay? It's consistent. 4, 1, -2, -5, -8. This is decreasing by 3 each time, okay? Right? If you minus 3 each time, it is, yeah, you get each number after that, okay? So that consistent change in the table is what makes that a straight line on the graph, okay? And so when it's not just a random collection of points, but when it follows a pattern like this, we can state that there's a rule, a function rule that goes with this, okay? And I'll tell you what this one is, and it again, this is pretty tricky. So the next video I'll go over how we can determine what the equation is if we're given this. But this equation would be -3x minus 2. Okay. And so just going over what that is, again, this is kind of saying this is a rule, and you notice it's like an equation, right? And it is an equation. That's another name for a function rule. Okay. But this is saying to find the y answer, to get the y number, here's what you do to the x number, okay? So you would take the x number, you would multiply it by -3, and then you minus 2 from that, okay? Let's just do that a couple times so you can believe me, okay? So when x is -2, okay, if x is -2, let's substitute that in to make sure that this works, okay? So if x is -2, I would be doing -3 times -2 minus 2, okay? And order of operations as I multiply first, so -3 times -2 would be 6, positive 6, and then 6 minus 2 does equal 4, okay? So that works, right? I got that y answer, okay? And one more, let's just go with 0. I'll do that up above here. If I said x was 0, so negative 3 times 0 minus 2. So negative 3 times 0 is 0. 0 minus 2 is negative 2. Okay, and I get that. So again, I'm a math teacher, so it's easy for me to say what that equation is. That's actually one of the trickier things we'll do this unit. So the next video, video 3, will be all about how we get those equations. Okay, but for now, yeah, just know that an equation or a function rule is another way that we can display some functions, right? I put another example up here. Let's do example number 2 here. Okay, so the directions, I listed the directions here. It says give a table of values for the function rule, which is just this. Again, function rule just means the equation that it gives, and then graph it. Okay, so in this one, we're given the equation or the function rule, and I make a table of values, and then I take those table of values and I graph it. Okay, and so with this one, the first thing you might notice is this weird symbol, this f of x. Okay, that's how you say that. We say that f of x. That's kind of how that's said. I know that's weird, okay? But notice that it's a weird symbol. That's called function notation, okay? That's something that you'll see with these, but just don't let that scare you, okay? Notice it's basically it's in the same place as y is, okay? And that's true here. It's just like instead of saying x and y in the table, we would just say x and f of x. Okay, it's function notation. It's one of those weird things you'll see in Algebra 1. But the math that you're actually doing is no different. Okay, so that's that. Okay, so what do we have to do? We have to give a table of values for the function rule and then graph it. Okay, so first thing I have to do is fill in this table. And how do I do that? Well, I need x values, right? And again, what I did was, right, in this first example, I had all the table already filled in. But what I would normally do is, right, I'd have a set of x values, and I would substitute those into the equation, okay, and then find the y answers as a result. And I'm going to do the same thing here. I'm going to just pick x values. In this set here, this negative 2, negative 1, 0, 1, and 2, is a good default set of x values to choose. So if you're not given x values, this is a good 5 x values to choose. Just it's kind of right in the middle of the graph, and it'll give you all that you need. Okay. So negative 2, negative 1, 0, 1, and 2. So I'm going to do 5 little mini things here. I'm going to substitute in each of these in for the x in the equation. Okay. And the answer after I simplify that will be the corresponding f of x value. Or again, it's the same as just y. So if that f of x is confusing, just think of it as y because it serves the same purpose. Okay. So really, again, I'm just worried about 2x minus 5. But instead of x, I'm substituting in these values. So it'll be 2 times negative 2 minus 5. Okay. Because again, instead of 2x minus 5, it's 2 times that x value is negative 2. That's the first one. So I substitute that in for x. And then I simplify that out. So negative 2 times negative 2 is negative 4. And then negative 4 minus 5 is negative 9. Okay, so negative 9 is that value there. Okay, there we go. And then I do the next one. So again, I'm just substituting in the x value into the equation. So 2 times negative 1 minus 5. And again, same thing. I multiply 2 times negative 1 is negative 2. Negative 2 minus 5 is negative 7. Okay, so negative 7 is the y value or the f of x value there. Same thing, I plug in 0 for x. So 2 times 0 minus 5. So 2 times 0 is 0. 0 minus 5 is negative 5. So now I plug in 1. Let me move these down a little bit. Plug in 1 and 2. So I substitute in 1 in here. 2 times 1 minus 5. So 2 times 1 is 2. 2 minus 5 is negative 3. And then I substitute in positive 2. So 2 times 2 minus 5. So 2 times 2 is 4. 4 minus 5 is negative 1. Okay? So there's my values. Okay, I'm going to erase those real quick, and hopefully you understand the work that I did. I wanted to show that, but it's a little hard. So let me erase that and just put the values in there. Okay, so there's my values. And again, once I fill that in, that is a completed table. I have 5 ordered pairs now, right? An x value that goes with a y value or an f of x value, okay? And so once I have that completed, right, I have my table of values for this function rule. And then now it's saying, then graph it, okay? So again, these are all points that I can graph on here, okay? So I do that, again, x and y-axis here. So -2, -9 be down here. -1, -7, 0, -5, 1, -3, and 2, -1. So again, you notice for this one, hopefully, straight line, right? Straight line, just like this one was, okay? So that's great, that's awesome. Every time you're given a function rule like this and you're asked to graph it, it should be a straight line, okay? That's a good way to check that you did it right. And what does that tell you as well? We just chose these 5 x values. Those aren't the only, x could be anything. X is an unknown value, and we just chose these 5. But if x was, say, 5, and I plug that in, it should also fall on this line here. Okay, so if I did the math there, 2 times 5 is 10, 10 minus 5 is 5. So 5 comma 5, right here, right, if I connected that, it would also be in line with that, okay? And for every other value that I choose, okay? So that's the deal. That's that. When we talk about function rules, we're talking about straight lines, okay? And so that's good. That's for that one. Okay, so I threw another example up here for you. Example 3. I'm just going to whiz through it. Okay, it's similar to this one. Just to make sure we got it, though, I'm going to do one more. Okay, so same directions. Give a table of values for the function rule and then graph. Okay, so I have this function rule. F of x equals -x plus 4. Okay, and I'm going to fill in the table of values, and I gave you the set of x values already. Again, I said that's a good one to go with for most equations. And so I'm going to find the corresponding f of x or y values to go with that, and then graph it, okay? So if x was -2, now this one's interesting because it's a negative x, okay? So -2 plus 4 would be when I plug that in, okay? Think of it as the opposite of x, right? Or the opposite sign of whatever x was, you change it, okay? So either way you think of it, this is going to actually result in a +2. +2 plus 4 equals 6, okay? So think of it that way, the opposite of whatever x was, plus 4. Okay, so if x is a negative number, you change it to become positive, and vice versa. Okay. So -1 in for x. So opposite of x. So opposite of -1 is +1. +1 plus 4 is +5. Okay. And then 0. 0. Opposite of 0. You can't have a -0, so we'll just stick with 0. So 0 plus 4 is 4. Okay. Opposite of +1 would be -1. So now it's negative. -1 plus 4 would be 3. And then opposite of +2 is -2. So -2 plus 4 is 2. Okay. And I didn't mention it in the last one, but again, I've said in the first one, a pattern. You should see a pattern in your table as well, right? A consistent, like that if the x values are going up by 1 each time, the y value should also be increasing or decreasing by an amount each time. So you see here, 6, 5, 4, 3, 2. Yeah, that's decreasing by 1 each time, right? So that's something we could say of this function rule. As x goes up by 1, y goes down by 1. So that's helpful to notice as well, okay? So once I fill in the table, then I graph them, okay? And so -2 is 6 right here. -1, 5, 0, 4. I erased those, sorry. 1, 3, and 2, 2. Okay, in a straight line, right? Straight line, that's how you know you did it right. There you go. Okay, so that's all I'm going to do in this one. Again, there's more to do, and I'll do that in another video, but that's all here, just a function rule and giving a table and a graph for those. So Good job.